We have the inverse sine of x over 2. We're going to take the derivative of that. We can see over here that the inverse sine derivative is equal to 1 over the square root of 1 minus whatever's inside of that inverse sine function squared. So in this case, what we have inside that inverse sine function is x over 2. And we'll have to bust out a chain rule here. But let's just do the first part. It's going to be 1 over the square root of 1 minus whatever this thing is squared. X over 2 squared. Then, of course, we have to multiply that by the derivative of what's on the inside. Keep in mind, x over 2 is the same thing as 1/2 x. So when I take the derivative of x over 2, if it's hard to think of it this way, you could think of it this way, but either way, you get multiplied by a half thanks to the chain rule. So I'm going to not even worry about this part right now. It's there because of the chain rule, but I really want to focus on this. There's a lot of nastiness here, a lot of other things happening. And when I have expressions like that, I'd like to focus on the most grossest part that I can first, that I know what to do with. So in this case, I'm going to focus all my energy right here. And I know that x over 2 squared is x squared over 4. So let's just copy everything else down. 1 square root 1 minus x squared over 4. All that's under the square root symbol. And this 1/2, I'm going to carry it around, but I'm not thinking about it yet. I got enough to worry about. The next thing that I notice is that these two guys, I can clean this up, right? There's two, I don't want to have a fraction inside of a fraction, the square root of the, that's bananas. Let me stop for 1 second. If this was a test question and you stopped here, I'd actually be okay with that. But if we're a multiple choice question, you're going to have to know how to do these next few steps. So let's carry on. I'm going to focus my energy here and know that it's just all I worry about is a fraction problem. They need a common denominator. This is technically over 1, so I can change that to be 4 over 4. So if I copy everything else down as it is, I have a 1 over the square root of, because these denominators are now the same, that whole thing is all over 4. And of course the top will be 4 minus x squared. And then this 1/2, I have to carry that around as well. Okay, looking better? It's helpful to know, too, that when you have the square root of a fraction, you can break it up as square root of the top over square root of the bottom. So then I can think of this as, excuse me, 1 over, it's like the square root of 4 minus x squared over the square root of 4 times a half. Square root of 4. Yep. And now, I'm going to use that trick where if I have 1 over some stuff, it's the reciprocal of that stuff. So this whole thing I could think of as the reciprocal of this, and the reciprocal of that is square root of 4, which is 2, over the square root of 4 minus x squared. So this entire expression I can rewrite like this, because I flipped it over, because it's the reciprocal of this, and I know the square root of 4 is 2. And this 1/2 that I've been carrying around, it's like right there, times a half. Oh, that's kind of nice, because if I have a 2 on top and a 2 on the bottom, they cancel. And my final answer will be 1 over the square root of 4 minus x squared. The end. That's how you get from this gross thing, which just applies the formula along with the chain rule, to this nice, pretty expression. And as I said, in a free response test or quiz, if you left it here, I'd be okay with that. But you should know how to get to here for the purpose of a multiple choice test or whatever.